Hi, this is a training video for Lancaster West staff about how to install temperature sensors for Build Test Solutions Smart HTC measurements. So these are the temperature sensors. They're pretty simple little machines. They've only got one button on the front. By the time you get to this stage, you will have already connected them to the computer and set them up. So you just need to press and hold the play button to start the logging. The only other feature on the sensor is this battery slot in the back. It's a coin twist and there's a coin battery inside which you can replace before the logging starts. So the whole point of these sensors is to get a measurement of the average internal temperature in a flat. So today we're in a studio flat. There's 3 rooms. There's this, the studio section, and there's a kitchen and a bathroom. So in this, we'll be probably looking to install 3 temperature sensors, one in this room, one in the kitchen, one in the bathroom. A good rule of thumb is that every big room should have a temperature sensor, or technically, your most accurate measurement is 1 every 12 meters squared of floor area, but 1 every large room is a good guide, good rule of thumb. So now we're going to look around the room for somewhere sensible to put our temperature sensor. We want to get a good measurement of the average internal temperature. So what we want to avoid is definitely not on top of radiators, because then you'll measure the radiator temperature and not the room temperature. Definitely not right next to windows, because if you get sunlight shining onto the sensor, it actually warms up the case of the sensor, and the sensor will measure that it's 50 degrees or something silly in here. So we want to avoid direct sunlight. Now, this is an empty flat, but there could be, you could imagine an electric fan heater or a television. So anything that's going to get warm enough that it might heat water is a good guide. You don't want the temperature sensor near that. So you're avoiding warm things, you're avoiding the sun, and then in the room, it's always hotter at the top and cooler at the bottom because warm air rises. So you want it to be about halfway up the room. So we're mid-height. We're in the main space of the room, so we're not hidden in a cupboard or something. We're avoiding warm things. And in here, you can see someone's already come and put a thermostat here, and that's because it's a good place for all the reasons I just mentioned. So I would take the sensor and maybe stick it on the wall here, because there isn't any furniture to leave it on. If there was a shelving unit or something here, it could equally sit on a shelving unit. We usually use a command strip to stick on the wall because it's got the pull-off bit, so you're less likely to damage the paint when you take it off. Okay, so now we're placing a temperature sensor in the kitchen. It's quite a small room, so it could be a little bit tricky here, and in kitchens there's obviously more sources of heat. So if I looked at this whole room, first thing I'm thinking is I've got a window here. I don't want it to be on the windowsill because the sun will shine directly on it. Then this little corner of the room might make sense, but there's a boiler in there. So that's definitely going to be warmer and we don't want to be right next to that. So that's closed out my options over here. I don't want to be too close to the cooker. So now I'm thinking if I put one on this wall, that would be okay. Or if this was an occupied flat and someone had a little thing full of kitchen utensils here, I could tuck it in that corner. I think that would be okay as well. Okay, so now we've been in the studio flat. We've put one in the studio, one in the kitchen, and we're looking at the bathroom. Again, quite a small room. Here's the radiator, so we don't want to be next to that. The temperature sensors aren't waterproof, so don't put it in the bath. So I think that leaves one obvious option, which would be on this little shelf. We're just away from the radiator there. We're not in direct sunlight, about mid-height. Really important to get one in the bathroom because you get a lot of heating in here and a lot of hot water use, so it's an important area to measure the internal temperature. Okay, so we need to take energy meter readings to measure how much energy consumption there is. These need to be taken at the start and the end of the temperature monitoring. And with the meter readings, I think it's always a good idea to take a photo. Then we've got a timestamp. We can check back and make sure that we've read the meter correctly because there's always loads of different types of meters, different units. It's easy to get confused. So here's a gas meter, it's in feet cubed, just a simple dial. So for that, I'd just be lining up my camera, quick photo, harder inside gloves, but I've got the photo there. So I've got date and time stamped meter reading. So I need a meter reading and the date and time it was taken. So the photo's perfect. Now we've got a key card electricity meter. The first screen we've got is how much credits left on the meter. So let's scroll through. And what we're looking for is the energy consumption. So here's energy consumption in kilowatt hours. Again, date and time stamp meter reading. Job done. Okay, so for Smart HTC, we need some basic dimensions of the flat. We need two things. One is the total floor area, and the other is the size and orientation of the windows. So for the floor area, this is a studio flat, pretty simple measurement. Here I can see right from front to the back of the flat, so I'll take my laser measure and get right to the front door. Where's my spot? Okay, got it turned on now, that helps. So laser measure right to the front door, 7.45 meters long, and then across 4.6 meters wide. So just times those two together to get the total floor area. If this was a 2-story flat, for example, a maisonette, then you just add the floor area of this to the floor area of the floor above. So you want the total floor area of the whole dwelling. So that's floor area, and now window dimensions and orientation. Here we've got a window that's not quite at the same orientation, but all I want here is the orientation of the facade. So which way does this wall face? I'd usually do that by just looking at Google Maps, seeing which direction this road is, or you might have a compass on your phone. So get the basic orientation, north, northeast, east. You don't need to be down to a degree or anything. I've got the sun here, so this is probably south-facing window. And then to measure the orientations, same again. I'm going to measure the dimensions rather than orientations. So it's 1.4 meters tall, 0.7 meters wide. So I'll do that for each window, add them up. That'll give me the total window dimensions and orientations for the flat. So for Smart HTC, if we're measuring the energy performance of an individual flat, it's really important that we know which flat, which dwelling, all of the sensors were in and the meter readings were taken in. So each sensor has a serial number. They're all unique. So if you take a note of which flat had which serial number sensor in, that's a good way to make sure that you get the data for the right flat. And then I also, if I was coming here, typically 4 sensors is a good number for a flat, so I've got a box of 4 temperature sensors. I take them away. I've put a little code on here for this set of temperature sensors, so I know that all of these came from one particular flat. So that's installing temperature sensors for Smart HTC.